In this video, we're going to do a couple of more remainder theorem type questions where we're going to find zeros based off of knowing one zero of a polynomial. So here we know x equals -5 is a zero. That tells us that one of the factors is x plus 5, right? Because x plus 5 equals 0 is how we would get x equals -5. My synthetic division, I'm going to put a -5 in the window, so that's what x equals. And then I'm going to have 1, 6, 3, -10. Bring down my 1. -5 times 1 is -5. Add to get a 1 again. So repeat. Okay, cool. When I add here, now I get a -2. -5 times -2 is a +10, which gives me a 0. Fantastic. This is my remainder. I need it to be 0 for me to have done this correctly, because I'm told that x equals -5 is a solution. Here's my constant. There's my linear. And there's my quadratic terms. So I'm going to have x plus 5 times 1x squared plus x minus 2. That's what f of x equals. F of x can be simplified a little bit further with my factoring process. X times x is x squared. 2 times 1 is 2. To make it a -2, one of them has to be negative. But when added together, they're going to have to be a positive. So I'm going to have +2 and a -1. This one says find the other zeros. So I've already been told what this 0 is. I now have this equals 0 or that equals 0. These are my other solutions. All three solutions, because I should have 3 based off my exponent of 3, would include -5, but it specifically said find the other zeros. Okay. Now, number 40 is harder because this one does not have x plus h, x minus h. There's something squared here. So what I'm actually going to do is see if I can rewrite things to make it a longer looking process that is simpler. Meaning, if I look at this last piece, can I figure out a way to factor x squared plus x plus 2? Because if I could, pretend with me for a second, because this is not going to work. If I could do this, I could take the top thing, divide by x plus 1, get something that's a little bit nicer, and then move on. I can't in this case, because we just saw up in 39, those are slightly different, but because of the +2, I had to use a 2 and a 1. I'm not going to be able to get my plus x. So I can't just go about my business that way, which is kind of annoying. I wish I could. So now, I don't really get to use synthetic substitution or synthetic division. I have to do this the long way. So, x to the 4th minus 3x cubed minus 2x. Oh, I missed an x squared. Better go back and put a plus 0x squared minus 2x plus 1 divided by x squared plus x plus 2. X squared times x squared gives me x to the 4th plus x cubed plus 2x squared. Subtract. X to the 4ths cancel. -3x cubed minus x cubed is -4x cubed. 0x squared minus 2x squared is minus 2x squared. Bring down the minus 2x. X squared times minus 4x is minus 4x cubed. -4x times x is minus 4x squared. -4x times 2 is -8x. Parentheses, subtract. These are gone. -2x squared minus -4x squared is a positive 2x squared. Negative minus a negative. Okay, -2x minus -8x, that's a positive 6x. Now we bring down our 1 with a positive 1. So x squared times a positive 2 gives me a 2x squared. 2 times x is 2x. 2 times 2 is 4. Parentheses. Subtract. These are gone. I'm going to end up 4x minus 3. And I end up with this piece right here. So when you're doing these, if you can use synthetic division, your process is going to speed up a lot. If it just says divide, you can use whichever method, except synthetic only works if you have x minus h as a form. This had a quadratic divisor, so you kind of just have to do long division. So make sure you know how that one works. Now, I tried to give myself room to work. I'll put a little gap spacer there so we know which piece is which if you go back and look at this later. Have a great day, everybody.